Okay, so today we're going to be talking about quadratic equations and quadratic graphs. So a quadratic equation will take the form y equals ax squared plus bx plus c. Now, you're going to want to be able to do two things with these, at least at GCSE level, and that is to find the roots of a quadratic equation and also to be able to sketch them. So first we're going to talk about finding the roots, as this is useful for sketching. So there's two main ways you can do this, and the first is through something called the quadratic formula. Now this states that the two roots, and essentially this is where the graph of the quadratic will cross the x-axis. Now typically it will do this 2 times, however this is not always the case, and we'll go into why that is later. But first we're going to have to realize that with a quadratic that's crossing the x-axis, at the point where it crosses the x-axis, the y value is 0. So y equals 0, and therefore we can substitute that back into this original thing, and we have that 0 equals ax squared plus bx plus c. Now we can see that this is an equation, since a, b, and c are constants, this is just an equation with x as the unknown, so we have to solve for that. And since it's an x squared, there's going to usually be 2 solutions. Now we can do this through, as I said, the quadratic formula, which states that using this, x equals minus b plus or minus root b squared minus 4ac over 2a. Now what this means is that depending on whether it's plus or minus, it will give you 2 different values for x, and these x values are the roots of the quadratic equation. And obviously the y value at this point is going to be 0, as we stated before, since it's where it crosses the x-axis. Now another way you can do this, you can find the roots of a quadratic equation, is by completing the square. Now, instead of just working with the constants a, b, and c, we're going to give them values. So instead we're going to have the graph y equals x squared plus 12x minus 5. And since y is 0, as before, 0 equals x squared plus 12x minus 5. Now what we're going to do by this method is we're going to take this coefficient of x, we're going to half it, and then we're going to square it. So what does that give us? Well, we have 0 equals, and then we'll put some brackets here, x squared plus 12x. Now what's half of 12? 6. What's 6 squared? 36. So we're going to do plus 36. And since this is the same thing, we have to subtract 36, or else the equation will just be different. Minus 5. So we have 0 equals x squared plus 12x plus 36 minus 41. We add 41 to both sides, we get 41 equals x squared plus 12x plus 36. Now what you should be able to notice is that this quadratic here that we have on the right-hand side of the equation is simply x plus 6 all squared. Because if you expand that out, you get this. And that's always the case, because if you're halving this and squaring it, you're essentially finding some x plus something all squared. So we're going to take the root of both sides. So we have plus or minus the root of 41, which is equal to x plus 6. And therefore, x is equal to minus 6 plus or minus root 41. So these are the 2 roots of the equation. Minus 6 plus root of 41 and minus 6 minus root of 41. So that's how you can find the roots of these equations. Now note, for completing the square, the value of a, or the coefficient of x squared, must always be 1. If this is not the case, you must divide the rest of the equation by that coefficient of x squared, and this will give you x squared plus, and then instead of just 12, it would be, instead of just b, it would be b over a. And then you can do the same thing from there. So now we're going to talk about graphing quadratic equations. Now a quadratic equation will have a parabolic shape. So if I were to draw some axes like this, right? If we just wanted to draw the normal x squared graph, y equals x squared would look something like this. So yeah, if the coefficient of x squared, so the a value, is positive, then we're going to get a curve like this, so like a smiley face. And if the coefficient of x squared is negative, we'll get a bit of a sad face. That's quite an easy way to remember it. Now, as you'll see, for most quadratic equations, it will intercept something like this, and therefore there will be 2 times where the quadratic equation crosses the x-axis. However, as you can see, like in this case, it just crosses the x-axis once at 0. And sometimes, if it's drawn just like above or below, it doesn't cross at all. Now, how you can tell whether there's going to be 2 roots, 1 root as here, or 0 roots, is by this thing here in the quadratic formula called the discriminant, b squared minus 4ac. If this value of b squared minus 4ac is negative, therefore, then you're going to have a negative square root, which is impossible, at least when you're dealing with real numbers. And therefore, there will be no solutions to this equation, and therefore, there will be no roots. So this is when it just doesn't touch the x-axis. If b squared minus 4ac is equal to 0, then you have square root of 0, which is 0, and then plus or minus doesn't make a difference, so you're only going to have one value, as is the case here. And therefore, you'll have what's called a repeated root, or as it looks, it's just one root. And then if this value is positive, then your plus or minus does make a difference, and then you're going to have one that cuts the x-axis twice. So we're going to give a bit of an example of, well, first we're going to look at how to find, as you'll see here, in any quadratic equation, there's always either a minimum point when it's a smiley face or a maximum point when it's a sad face. So this is the stationary point, they call it, right? It's the point where the slope of the graph is at that point 0. Now, we're going to approach this from a differentiation perspective. So you can see our other video on differentiation if you want some help on that. So if we take the equation y equals ax squared plus bx plus c, we can differentiate this to find dy by dx, which equals 2ax plus b. And at this point, this stationary point, dy by dx, or the slope, is going to be 0, as we said before. So therefore, 0 equals 2ax plus b. Now rearranging this for x, which I hope you can do, we get minus b over 2a. Therefore, the x value of the stationary point of any quadratic will be given by minus b over 2a. Now let's do an example of that, finding the stationary point of some graph. So we're going to use the example y equals minus 1.2x squared plus 4.8x minus 3.8. So, as we said before, the x value of the stationary point is going to be given by minus b over 2a, which is minus 4.8 over 2 times minus 1.2, which is equal to 2. Now we can plug this x equals 2 into the y value, into the original equation to give us our y value, which will give us our stationary point. So y equals minus 1.22 squared plus 4.8 times 2 minus 3.8, which, if you solve that, will give you 1. Therefore, the stationary point is 2, 1. And since the coefficient of x squared in this is negative, therefore we're going to have a sad face, and the stationary point is going to be a maximum point. Now, we're also going to want to find the y-intercept of this equation, and this is really easy actually, because if you think about it, the y-intercept of a quadratic equation will come when x is equal to 0. So if we look at this equation, when x equals to 0, so this becomes 0, this becomes 0, all we have left is that minus 3.8. So therefore, the y-intercept is going to be at y equals minus 3.8. So that's important to note, since we're going to want to sketch this graph. So now finally, since we have the y-intercept and we have the maximum point, all we're going to want to do now is find the roots of this equation, and then we'll be able to graph it. So we're going to do this, since these are not particularly nice numbers, we're going to want to use the quadratic formula. So x equals minus b, so minus 4.8, plus or minus root 4.8 squared minus 4 times minus 1.2 times minus 3.8 all over 2 times minus 1.2. Now if we put this into a calculator, this shows that x is equal to 1.087 ... and also 2.913 ... So therefore these are our two stationary points. So finally, if we want to graph this, we don't have a lot of space here, but let's just draw it here. If we wanted to graph this, so this is our y-axis, this is our x-axis, right? We know that the maximum point will be around 2, 1, which you can say is roughly around here. Remember, we're just sketching this, so it doesn't have to be an exact graph. So 2, 1. We know that it crosses the x-axis at the points 1.087 and 2.913. And we know it crosses the y-axis at minus 3.8. So minus 3.8, 2.913, 1.087. So the graph will look something like that. And there you go. That's how you sketch quadratic equations. And this is basically what you need to know. Thank you.